Hey everyone, welcome back to Science 9. I hope you had a great long weekend. What we're going to do this week, we're going to start our next unit on electricity. So we're going to cover this for the next 3 weeks. So the big ideas we're going to learn in this unit, we're going to learn just some basic tips about electrical safety. We're going to learn what electricity and electric current actually is. We're going to go over how voltage, current, and resistance are related, and we're going to do some simple calculations using Ohm's law. And then we're going to go over circuits. We're going to go over the basic parts of a circuit and the different types of circuits. And this just kind of elaborates more on that, the 6 big things we're going to learn about. This week, we're going to learn about the first three: voltage, current, and resistance. We'll talk about the parts of a circuit next week. We'll talk about the different types of circuits the following week. And we're actually going to go over some electrical safety this week as well. So to begin, we're going to talk about voltage. And what voltage really is, it's electrical potential energy. So it's energy that's stored, basically, is what potential energy is. Um, And just to kind of draw a comparison to other types of energy, potential energy is basically just an object that has the ability to do something. So if it's like in this picture, a ball being held high in the air, so it's not moving when that person's holding it, but as soon as they let go, it starts accelerating towards the ground. And that's because it has the potential to fall. And when it does start falling, the potential energy gets turned into what's called kinetic energy, so it's moving. So that's one example of potential energy. Another example is this bow and arrow. When the person draws the bow back, it has a ton of potential energy. It's not moving yet. As soon as they release the bow, it doesn't have any potential energy left, but it's all this energy is being converted to moving energy, kinetic energy. So electrical potential energy is like that. It's energy that's stored in something like a battery, and then once you plug it into an appliance or something like that, it starts being changed into other type of energy. But that's what voltage is. So remember that atoms, they're made of protons, neutrons, and electrons. So the protons are positive, the electrons are negative. When those opposite charges are separated, so when the electrons are separated from the protons, they want to get back together, and then they have potential energy. The electrons want to flow back towards the protons, as we see in this simple diagram here. So this is a battery. The protons have been separated from the electrons, and there's a barrier here, so they can't flow back this way. So they want to flow back to the protons, and that's electrical potential energy. Obviously, the greater the difference in the separation of charge, the higher the voltage. And that's why you see different voltages between different batteries. Voltage is measured by a voltmeter, and the units it's measured in are volts. And here's a couple pictures. Here's a nicer voltmeter, and here's one of the ones we would have used in school, just a simple voltmeter. So once the electrons start moving, so like once the battery's plugged in, the potential energy turns into electrical energy and the voltage goes down. And then that energy gets turned into other types of energy. So you don't need to know this for the worksheet or anything like that, but if you're curious on some ways that voltage is created, it can be created in a lot of different ways. One way is through like chemical reactions in electrochemical cells. Batteries are a good example of that. And there's just a couple quick links here. If you want to see how you can make a battery out of just vinegar, pennies, and tin foil, it shows you on this video right here. You could also make batteries out of pieces of fruit like lemons, if you just have a couple wires and a couple different types of metals. We were going to do this lab in school. So if you're curious about that, take a look at that. Voltage is also created by the energy from the sun, solar energy. So if you're curious and you want to watch a couple of these videos, how certain types of atoms, they actually just have their electrons knocked off them, and that creates an electric current. Or they could be, voltage can be created using generators, and that's when it involves moving a magnet close to a wire. Again, you don't need to know that, but if you're curious, that's how we get our energy here, through hydropower, where water will flow through these turbines, which turns a magnet. So if you're interested in that, take a look at that. Coal plants also generate energy that way, same with nuclear. So if you're interested, have a look at these. The next part of electricity we're going to go over is electric current. So when the electrons are moving, that's electric current. And they need to flow through a wire or some other type of conductor. So in this simple diagram here, there's a battery, and the negative end is connected to the positive end through a wire. And you notice it goes through something else. We'll talk about that next. So what current is, it's the measure of the flow or speed of electrons, how many flow per second. It's kind of like current on a river. Current is measured using an ammeter, and the units it's measured in are amps. So this is an ammeter like the ones we have at school right here. And there's a picture of an ammeter in a circuit, which we'll talk about next week. Just some more on the current here. So not only are the electrons attracted to the positive charge, but they're also pushed along by the repelling each other. So here's an example of a simple circuit. Negative end of the battery, these blue flowing things are electrons, and they flow around to the positive end of the battery. And we'll talk more about circuits next week. The next basic part of electricity we're going to talk about is resistance, which is when things slow down the flow of electrons. Here's a symbol for resistance. Resistance is measured in units called ohms. Here's a symbol for ohms, and it's measured using an ohm meter. So loads are things that slow down electrical current. They turn electrical energy into other types of energy. They're like resistors. And some examples of loads here, light bulbs are loads. They turn electrical energy into light and a little bit of heat. Motors, so electric motors, they turn electricity into kinetic energy because they move. Radios turn electricity into sound energy, or like your phone turns some of the electricity from the battery, if you're playing music, into sound energy. Heaters turn it into heat, which is thermal energy. Lots of other examples. So that's basically what loads are. They're types of resistors that slow down the electric current, and they turn it in from electrical energy into a different type of energy. And just kind of a little introduction into next week. So in order for electricity to flow through a complete circuit, you need these three things. You need the source of energy, which is the energy for the battery, which creates the voltage. You need a conductor, a wire that allows the electric current to flow through. And you need either a load or a resistor, something that slows down the electricity and turns it into other forms of energy, which we'll talk about next week. Here's a really basic picture of a circuit. So the last thing we're going to talk about is just a brief introduction to electrical safety, go over the dangers of current and voltage. So just some general guidelines about electrical safety. Never do anything, don't stick anything into an outlet other than a cord, and a cord that's not damaged. Never stick a metal object into a toaster if you're having trouble getting your toast out or something like that. Never use a cord that's frayed. so it's kind of like broken in little parts. Never touch an exposed wire unless you know that the circuit is shut off, unless you've shut it off in your electrical panel and you've tested it with either a ammeter or a voltmeter. Never have an appliance or a phone plugged in near water, so don't charge your phone if you're in the bathtub. I'm going to show you this article of actually a young girl who passed away doing that. Never go near down power lines, or just never go close to power lines in general. Don't fly a kite near power lines or put a ladder close to them or anything like that. So here's the article I was talking about. It's a sad article. A 15-year-old girl in Russia died charging her phone. She just had it beside the bathtub. I don't know if she was playing music on it or what, but fell into the bathtub and electrocuted her. So I'd like you to take a look at this article. And there are 4 safety videos I want you to watch here, these 4 links. And these come into play when you're doing the assignments. So just to finish off this slideshow, you don't have to watch any of these extra help videos, but if you need more help with this or you want some further information on this, there's some short videos and then a Bill Nye right here. And then if you want to look at some extra safety videos for electrical safety, these are on here as well. So the assignment for this week is a Google Doc. So I'm going to pull it up here. So with Google Docs, you just make your own copy and then you're able to edit them by writing your answers in here. You save it as your own and then you could resubmit it to me. So the first page are all just general questions on voltage, current, and resistance. And then for the second page, I'd like you to watch each of those 4 safety videos. They're 2 to 5 minutes each. And then after each of these videos, I want you to describe one thing you learned from each of the videos. So the first one right here, electrical safety at home. It's a 5-minute video. I'd like you to watch this video and then write down one thing you learned about it. Crane truck contact. So this one right here, where these guys back this crane into a wire. I want you to watch this and describe one thing you learned about that. This video, electrical safety tips, it's a 3-minute video, same thing. And then the last video, electrical panel safety, that show you how to turn on and off circuits in your house. I'd like you to watch that, write one thing you learned about that, at least one thing, and then hand this in. And then next week we'll go over electrical circuits. Okay, that's it for today. Thanks guys and have a great week.